Hey there, I'm Diane Lee. I'm ISI Marketing and Communications Director. Thanks for joining us today live. It looks like we are having some technical issues on LinkedIn again. I gotta explain, that's my fault. I changed my name on LinkedIn, and ever since then I've been struggling to connect them. So if you're seeing us on LinkedIn, great. But it looks like we're not. We are on YouTube though, so I'm hoping people hop on over to YouTube so we can talk about bridges today, sustainable bridges and sustainable bridge technology with AIT Bridges, also with Infrastructure Ventures. I'll turn it over to my guests real quickly. They can introduce themselves and tell us a little bit about them. Ken, we'll start with you.
So I'm Ken Sweeney, and I'm President, Chief Engineer of AIT Bridges, and we're a composites company.
Greg Netto, I'm Chairman of Infrastructure Ventures, and we basically, our logo is we build bridges between private sector innovators and infrastructure owners. So in a nutshell, that's what we attempt to do in service to public infrastructure.
I love it. I love to hear the slogans. Today, I want to talk to you, getting some reverb too. You know, live, you just never know. Murphy's Law, as I say. So I'm going to step back a little bit. Hopefully that will help. And maybe I might even see if I can put some microphones on mute and see if that helps. All right. So we all know, it's no secret that Americans' bridges are in desperate need of repair. Thousands are needing to be rebuilt. We're talking about one bridge today, the Grist Mill Bridge, which is kind of historic in ways. Why don't you tell us, Ken, about what makes this bridge pretty special, especially for you guys?
So, to begin with, the bridge is located in Hamden, Maine. It's on Route 1A, which is a connector between the coast and the nearest largest city, which is Bangor, Maine. And the importance of this connection is that from Bangor you can get to the national park, you can get to the coast, and it is really central to the transportation system in I guess it's not quite northern Maine, but it's mid-Maine. So with that, one of the things is that this bridge was really the linchpin of an entire series of projects that have been going on for probably around 15 years. And this is the last connector. And it also, the bridge itself, the existing bridge, was narrow. It was in need of repair, and so the Maine Department of Transportation came in and wanted to replace the bridge. And so at the same time, what happened was that the University of Maine and AIT had been working probably about 3 years in research and development to bring composite technology to the infrastructure, to the bridge market in terms of the G-beam. And so, things kind of coincided with that. And so Maine Department of Transportation and AIT got together and decided that this would be the perfect structure, the perfect bridge, the perfect location to roll out this innovative technology. And so the design of the bridge itself, other than, this being a connector, the bridge itself is certainly a lot wider. It provides a sidewalk, and it provides, a safe area for pedestrians. It also is a connecting sidewalk so that you can go all the way from Hamden town center all the way to Bangor without walking on the shoulders or out in the street, and do so safely. So the composite technology itself, in terms of the G-beam, is, composites have been around for a long time, as people know, but it's a very sustainable material in its manufacture, but also it's durable and lasts much longer than traditional bridges of steel and concrete. as much as, 25, 30 years longer, and virtually requires no maintenance through its lifetime. So, that's obviously a big piece. As you know, as was mentioned earlier, the infrastructure in this country, steel and concrete, has really come near the end of its life in a lot of these structures. And so the composite, by replacing it with something with a new material that is better able to handle the environment and last as long as composites will last, it seemed to make sense, because as we know, budgets are tight, and a lot of DOTs defer maintenance on structures, and so a structure that is going to require little to no maintenance is obviously going to be positive effect on their budgets going forward. And so, at AIT Bridges, we're bridge engineers, and we use composite materials. So with that, we can move on.
But you missed the best part, the fact that it is the first in the nation. Did you say that? It's the first in the nation, right?
Yes, it is. Yeah, and composite materials have been used in various other places, but not as done in this bridge. In other words, the G-beam is a new product, and the fact that this bridge, the new bridge, is 75 feet long, and having a composite that can handle the loads. This bridge was fully load tested once it's was complete. In fact, we just had the ribbon cutting, but before we did that, they loaded it up with around 260,000 pounds of truck in the center of the bridge, and the deflection of the bridge was less than half an inch. So
wow, it's strong.
It's very, very strong, and that's, sometimes people talk about composites and think of them as not able to handle the heavy loads and things that you would normally expect in infrastructure. But in fact, composites have been around a long time, and the materials and the fabrics and the resins are getting better and better every day. So I think it's important that we certainly hope, and we have seen signs that this innovation is being adopted around the country. We've got projects going on now in Florida, and soon to have projects in Washington State and Illinois as well. Rhode Island is another project that will be done this fall. So the bridge engineering community has picked up on this innovation. They like what they see. It's lightweight, and it's installs very quickly and with a lot smaller equipment. Transporting it to the site, you don't need, you can put a whole bridge on one truck if you need to. So it's really helpful to be able to do that to the contractor.
Can save money in a lot of different ways, and a lot of time as well. You know what? I want to show the video so that they can see what it looks like, and just get an idea from Maine DOT exactly how awesome it is. So here, I'm going to show a really quick video, 1 minute and a half. Hold on.
I love new products. I've gained a lot of faith in composites and this type of technology over the last year and a half of watching this system done. There's really no guesswork. We know what the materials in these girders are. We know how strong they are.
What they're doing today is they're creating a module. They're taking 2 of the girders and linking them together, and then installing the utility pipes, and then they're going to lift that module into place. Step 2 is to put the center girder in, and then step 3, which would be the final step, is to set the other 2 upstream girders in the same method that they're doing these downstream girders.
It feels good to make some history. We are a believer in this product. Our bridge engineers asked to use this. There's a sustainableness about this girder, not as energy intense as other products. People are going to start to really think about sustainable products. There's a lot of studies going on right now about construction emissions. And I think you're going to see that they're higher than we all thought. Part of our obligation as departments of transportation is to really extend the life of our bridges moving forward and using materials that may be innovative or new and seeing what they do for us.
Cool. Great video, by the way. You guys have a name that's called the Sustainable Bridge Story, right?
Yeah, and I think the other thing that I'd like to mention about this particular site, if you saw, the stream itself, what's unique is that it's a tributary of the Penobscot River, which is a salmon fisheries, and bringing back salmon into these tributaries is very important, and this bridge helps that. In other words, we know that salmon migrate upstream here, and providing this, if compared to what was there initially, is certainly a huge improvement to the waterway. And then the other thing is, you won't have to go in underneath and do any maintenance for well over 100 years, and that staying out of the water and letting the natural water course, grow up and continue to be healthy.
Yeah, do its thing. What I'm going to do is I'm going to show some advocacy photographs, because you guys had Susan Collins, Representative Susan Collins, who took notice of what you're doing up there and had a ribbon cutting ceremony. Maybe you guys could tell me about this, how this all came about, the interest from the federal government, and just and what part do you play in all of that? Greg, I'll unmute you so that maybe you can talk to us about that.
Yeah, Senator Collins has been a longtime champion of a number of initiatives at the University of Maine, Advanced Structures and Composite Center, which has been around 3 decades. And as an institution, they have really become global leaders, and that certainly applies in terms of structures and in terms of specifically the use of composites in bridge building. So the federal government, in a number of ways over the years, has funded in part demonstration bridges, not only in Maine, but in a number of states, which is essential to advancing new technology to what I basically capture as the Federal Aid Highway Program, which is big federal money that gets matched by state and locals. The total pot of money becomes $110–30 billion a year that we spend on our highways and bridges. So the federal government plays a very important role in a number of respects. Research was conducted and funded by the Army Corps of Engineers, a terrific partner of the center in a number of ways. So the advancement of technology is critical, and government funding, government policies, incentives are all very important to moving it along. Yeah. We generally, as human beings, let alone bridge engineers, which I like to say my friend Ken Sweeney is one of the best, are no different than us. You're most comfortable with that which you know best. And if you've practiced bridge construction for 20 or 30 years, you've practiced the art and science of basically steel and concrete. We've been building bridges pretty much the same way for about 70 years. But when you think about the advancements, back when just for the purpose of creating some context, I spent 27 years in state government. Part of that was as deputy commissioner of Maine DOT, where I worked with Ken Sweeney and the woman you saw in the video, Joyce Taylor, who is really one of the nation's finest chief engineers and really a leader on a national basis, really spoke directly to the technology, to the benefits, to really the the readiness of this type of composite technology, whether it's our particular system, other companies manufacture their own pedestrian bridges. There's a lot of composite related technology that can add the same benefits Ken described. So as an industry, as really the owners in our system, which are principally state DOTs, they play a crucial role in the advancement of technology across the board. Not only in the context of the part of the program that they run, the bridges that they own, the state and federal highway systems that they're responsible for, but they're actually more locally owned bridges than state-owned bridges in this country. So you've got counties and local governments, and I understand your audience is a good chunk of engineers, and probably many of them at the local level. And they struggle with the most difficult obstacle, and that's funding. So the opportunity to, one, build a bridge that is sustainable, that has a longer life cycle, that requires little to no maintenance, from the standpoint of a burden on a community that has the responsibility for that bridge, it's huge. So, but in order for state, local, and county agencies to really be comfortable advancing the use of this kind of technology, it's very important that the state DOT, which is really the market leader, adopt the specifications and indicate to the locals that it's a technology that they've utilized, and we're blessed now. We've got a number of states. We just built our first bridge. It wasn't a girder bridge. It was one of the arch bridges that we manufacture. And we just built our first one on the West Coast in Washington State, and they just couldn't have been more excited with the outcome. And we're having serious conversations with other states in that region. So, I like to say that sustainability is becoming a policy prerequisite. And what I mean by that is sustainability, and I really consider it a movement right now. And certainly with the Biden administration in office, it's a it's really a priority. Three pillars, climate change of really the Biden administration, and of course growing support in Congress. So there's a real opportunity for policymakers to lead the way and adopt the specifications. A number of states have built a number of these bridges over the last decade to 12 years. And that means that it's tried and tested. But the reluctance of a lot of institutions to advance new technology is there. Federal government can incent that, state DOTs can incent that, can make the decision to simply be innovative and do it. So a lot of what I'd like to talk about whenever I have an audience of this nature is the leadership role that bridge engineers particularly play in these local and state infrastructure agencies, in this case, transportation agencies, the bridge community. They have an enormous influence on the direction that technology goes in this sector. So as Ken pointed out, that is clearly beginning to catch on. The knowledge base is expanding, and we do a lot of work to engage with those institutions and advance those that understanding, because the faster we can incorporate this type of technology in a state or a local agency, you're doing two things. You're incorporating a technology that will bring all the benefits that Ken described, but you're also going to bring the ability to build faster, better, smarter, and more innovative, which means you can do a lot of different things on a lot of different bridge sites. So it's important to create competition in the marketplace. So if all you have, and typically, generally, all you do have is precast concrete and steel as the principal, choice for materials, when you introduce composites into the marketplace, you introduce a new material which provides, in some cases, many benefits and as compared to the alternative, and you also create the opportunity to lower prices. That's what competition does in the marketplace. So if you're a state that has not yet begun to incorporate this technology in your bridge program, then you're probably leaving money on the table. So that's kind of our message, and how we want to engage with state institutions and the federal government to do all we can to provide incentive funds, to provide policy guidance, Its time has come, and clearly, with the sustainability movement is growing as it is, it also provides a lot of opportunities and benefits to these owners to do some sustainable practices and utilize some sustainable materials in a really core part of the infrastructure business. Nothing is more core and vital than bridges.
Yeah.
So that's our message, and that's kind of what we do in partnership with. And I'm also, by full disclosure, a member of the board of directors of Advanced Infrastructure Technologies, and work closely with AIT Bridges across the country to help advance the technology. So when I left office, I retired from government as administrator of Federal Highway Administration at the end of the Obama administration. And one of the first conversations I had was with the chairman of AIT, Britt Svoboda, to the opportunity to serve on the board of a company that was founded by the University of Maine that I worked with back in the day, and the opportunity to really showcase Maine-based technology, developed the University of Maine, really optimized by the work of AIT over the years. The plant is located in Brewer, Maine. So for Ken and I, it's a labor of love because you see the potential of this technology on a national and global basis that was developed at the University of Maine with the help of state and federal resources to make this happen. So it's a great example of how working together we can really advance and bring to the market new technologies that'll have long-term benefits to the public.
Well, everything you said, I agree with. I will say that we, as ISI, we can't take sides, but we can teach and educate people about what's out there and teach our ENBSPs what the new technologies are, or the newer technologies that they can use to make their projects sustainable. And our message is pretty much the same here. We're trying to get Envision awareness out there because we want, on a federal, state, local level with owners, we want them to understand that sustainability is not an option. Sustainability, resilience, and equity are must-haves in our going forward. And it's going to make a difference for everyone, for every community, if we start building sustainability in mind.
And if I just add one more thing, it's a very good point. Having said all that, believe me, there's a crucial role for steel to play in long-term infrastructure development. It's always going to be a critical element in the supply chain. Precast concrete. Our company is in the composite rebar business, and the ability to make more sustainable through a lot of the work the concrete industry is doing to reduce the impact they have on the environment, to utilize non-corrosive reinforcement. A lot of things you can do to make these other materials more sustainable, and those industries are certainly working on that. In certain applications in bridge building, I've come to learn in the years I've been observing this, I'm not the engineer, but I study them and I listen to them intently, that it's really remarkable that what this technology can do for certain applications, not for all applications. So this really is, it's a function of making sure you get all the tools you need in the toolbox to get the best result for whatever bridge you happen to be building. And that's why I say what state DOTs can do is really add this to their inventory. It's not necessarily replacing others. Traditional materials will always play a role, but I think you need to introduce composites in order to have all the tools you need in that toolbox to maximize your sustainability and your longevity and a lot of the benefits, again, that I think Ken can talk more about.
Well, let's do this. Let's wrap up. And what I'm going to do next is try to do something a little different so we can go live on LinkedIn. So stay with us. We'll close out this session on YouTube and see if we can't try something a little bit different to maybe go live on LinkedIn. So hang on, okay? Let's close this one out.